Hello, everyone. In this lesson, I'm going to cover integration by substitution. I'm going to start with simple, easy ways to do it. Not easy way, it's for the simpler way to do it for simpler cases. And we get to a little bit more complex situation. There are actually two versions of substitution rule, and there's one version for indefinite integral, which is this version, and the other one is for definite integral. This latter one it has more things to taken care of, but the idea is the same. They both to find families of antiderivative or finding area underneath the curve. Okay, so let's start from the first one. The first one, first we understand the rule, right? If you look at the rule, right, this looks like, see, we have a situation for indefinite integral, right? And we have f of g of x. And then we have a g prime of x and dx. If we have this situation, we can substitute g by u. Okay, so f of u. Okay, so what so here I'm going to write it. U is g of x, right? So then derivative of u with respect to x, it would be g prime of x, right? So as we substituted g by u, and what is g prime multiply dx? From this relationship, you can see if I multiply both sides by dx, u would be equals to g prime x multiply dx. So this whole piece is replaced. Okay, this whole piece is replaced. This whole piece, right? See, d is replaced by u, so f of u, and this whole piece is replaced by du. So it becomes a simpler integration. Okay. So if you look at it from the composition's perspective, we have worked on this on chain rule, but this is more like the reversal of chain rule, right? Because it's anti-derivative. Chain rule is on derivative, differentiation, and this is anti-derivative. Take an example. Okay. So here we got some examples. Take the first one. Okay, take the first one. We have cosine 2x dx. Right? How do we differentiate that? We know the antiderivative of cosine x, but we don't know the antiderivative of cosine 2x, right? So if we assume 2x is a u, right? If we assume 2x is an u, right? We're given the hint in that question. But if we assume 2x is an u, right? We will need a du. We need a du, right? So we need to have d. Okay, let me write it down. Okay, because u is equal to 2x, right? So du over dx equals to 2, right? So dx from here, I will get u wait, du equals to 2 times dx. And what is, because we want to have du in our next expression, so dx equals to half du. Okay, so in this part, right, in this part, as we're substituting everything in terms of u, we can write cosine u dx will be replaced by half of du. So that's one perspective to see this. And now we have half, we can bring the half outside, and integration. This is the indefinite integral. We have a cosine u du, and the rest of the integration will be much easier. Okay. The other way to handle this is also utilize this relationship. Okay, whichever way is convenient for you. Okay, because our goal is to make situation like this, right? We have it in the box, right? So knowing u is 2x, du is 2 times dx, right? So what you can do is that on this piece, you already have the u, right? And 2 times dx is du. So you're gonna multiply by 2, so 2 times dx we have it. But we multiply by 2, we also have to divide it by 2, right? To keep the equal sign balanced. So this 2, we can move it inside derivative 2x, right? So you can see it that way. And that's u. There you go, right? So the same thing. So in the end, what do we get? In the end, we get half the antiderivative of cosine u du is sine of u. Sine of u. And of course, we need to add a big fat constant, but this is not over. We have to substitute u back in terms of x. So the last step will be replacing u by 2x, and then we are done. Okay, so this is the first example. Let's look at the second example. Okay, let's look at the second example. The second example is like this. Okay, substitution, right? We have x e to the power of negative x squared dx. We are already given the hint, right? We want to assume u to be negative x squared. How do we do the substitution, right? Well, we're going to, since we follow the hint, u equals to negative x squared, and we want to change it to du, right? So we're gonna do du dx. We take a derivative, basically, take derivative of u. That's going to be negative 2x dx, right? In the given expression, we can move the x to be closer to, x times dx. To get x times dx, if we can multiply by a negative 2, right? So this is going to be u, we need a negative 2, right? So we're going to multiply by a negative 2, so we can match the whole thing. When we multiply by negative 2, we have to divide by a negative 2. So 1 divided by negative 2, and then you can put the negative sign in front. So by this time, we will be able to turn that this is a u, and this piece is du. Oops, I made a mistake here. This is a negative 2x. Okay, so I should write one more step. Du equals to negative 2x dx. Okay, forgive me. So negative 2x dx, negative 2x dx, that's du. So I'm going to replace the whole of it du. Okay? And the antiderivative of e to the power, so we're going to, that's going to be 1 over, it's going to be e to the power u, right? And plus a big fat constant. And at this time, don't forget to substitute that u back. Oops, my bad. Okay, so we're going to substitute u by negative x squared. And that's it. We're going to leave the rest of those questions for you, okay, for you to practice. And I'm going to move forward with some examples to work on substitution method, okay, to work on substitution method. Let me see if I can make the font a little bit larger. Okay, I'll be doing the odd number. I'll be doing the odd number, okay? So you can see some of these are going to be, it's going to turn out to be easy, but this is a technique you must learn how to do for your next course. And besides, I will be putting some questions like this on the exam, okay? So you have to, you know, work it. You have to work it. All right. So let's look at number 7, okay? Number 7, okay, we got x, 1 minus x squared, okay, dx. What are we gonna do, right? I suggest we assume u equals to 1 minus x squared, okay? And then u, whoops, what did I get that? Du dx, the derivative of u is equals to negative 2x, right? That is to say du equals to negative 2x dx. So look what we have. We came to the a similar situation as we did before, right? Except that this time we're going to bring the x. Okay, let me write just one more step. We're going to bring the x over to dx. So just to make it easier to see, you don't have to physically do that. And then we also need a negative 2, right? We'll have the x dx, we just need a negative 2. So we need a negative 2. We multiply by a negative 2, so we'll have to divide by a negative 2. Okay? So by this time, we're ready to do the substitution. Okay, so this piece is u. And this piece is what? du. Almost done, almost done. So what is the antiderivative of it? And that will be equals to, we keep the negative half, and we use the power rule, right? And that's going to be 1 over 1 plus half, power rule. So u to the power of 3/2, right? 3/2. And plus a big fat constant. So toward the end, we will have negative half, right? We have a negative half here. And what about this, right? This is going to be 1 over 3/2, right? 1 over 3/2 is 2/3. And 2 and 2 reduced, right? So we're going to bring the rest in place. One more step. One more step. We got a negative 1/3. And substitute u by its equal, okay, which is 1 minus x squared, 1 minus x squared to the power of 3/2. Okay. And plus that big fat constant. Done. So that seems to be pretty straightforward, right? That seems to be pretty straightforward. But I will work number 13 to show you. 11 is similar to cosine 2x we did earlier. Okay, so let's look at number 13. We have this integration of dx over 5 minus 3x. How shall we do the substitution? Obviously, there's no ready formula for s, but we can do this. Right? This is a linear. This is linear. So we're going to assume u equals to 5 minus 3x. Derivative, okay, du dx equals to -3, right? So du is equals to -3 dx. So du dx is only a different by constant, right? To get to du, we need a -3. So I'm going to write this whole thing the following way, right? So I'm going to bring this dx to the side. I need a -3x to go with it, right? So I need this, I can put this here, -3. I multiply by -3, and I need to divide by -3, which is -1/3. So this time, this way, the negative sign will be balanced, right? So the derivative, it's better I keep it that way, right? Keep it -3 outside. How about that? Okay, this is better. Even though there's no difference, right? I can also do this, okay? I can also do 5 minus 3x. Okay, that's du, which is a -3 dx. As long as they're equal, because they are equal, this equals to the derivative of, this is the derivative of u, because that's u, right? Derivative of u is -3 dx. So next we just have to substitute completely by u. So let's see what we get. We get, this is a u, and that is a u. Antiderivative, -1/3 ln absolute value of u plus c. And don't forget to replace u by its equal in terms of x. Oh, sorry. What did I do? Yeah, I can do copy and paste, right? So replacing u by its equal in terms of x. Done. Finished. Okay. Number 15. This is actually rather typical in a simple case. Rather typical. So we have a cosine to the power 3 theta. Okay. Cosine to the power 3 theta. Multiply sine theta. D theta. D theta. So how do we do the substitution? Obviously, we need to do something, otherwise it's pretty hard to integrate this, right? So we are going to assume u equals to cosine theta. Okay? Why? Well, you'll find out. You experiment, right? And you'll find out. The derivative with respect to u equals to negative sine theta, right? Oh, wait, d theta, sorry, d theta. And so as a result, du equals to negative sine theta d theta. Okay? And we have sine theta d theta already. So you just put a negative sign in front of it. Okay? So next we will have substitution. Cosine theta is u, so this is going to be u to the power of 3. And this piece is the negative du, right? This piece is negative du. So we can pull that negative sign outside. We have u to the power of 3 du. Power rule. So we get 1 over 3 plus 1 is 4, u to the power of 4 plus big C. Okay, one more step. Substitute u back by its equal, which is a cosine theta. Okay, so we have cosine theta substituted in place, and this theta is going to be placed there. Okay, note it. Okay, please note. Okay, when we do the substitution, u to the power 4, okay, equal to cosine theta to the power 4. That's not a problem, okay? But this also is written as a cosine to the power 4 conventionally. All right, so that was that. I urge you guys to practice this. Please do practice, okay? I will do a couple more. For example, number 21. Number 21, this is colored, right? Colored means it's a little difficult. But you'll find out, I think. All right, ln x, ln c, ln x squared over x dx. What are we going to do about it? So here we go. Let u equals to ln x. And du dx equals to 1 over x. So that means u is equal to 1 over x multiply dx. And we already have it. See? In the given, right? Dx over 1, dx over x. That's du, right? And u is ln x. So we got u squared multiply du, because dx over x, that is du. Dx over x, that's du. And almost done. 1/3 power rule. U to the power 3 plus the big constant. In the end, okay, we have 1/3 u, which is ln x, right? Ln x will be powered to the 3rd power plus constant. Finished. Okay. There's some other examples, and I think I probably save it for another video. So first, I want you guys to try and practice, okay, and get the hang of it. Okay, there's some other examples that I will go over another time, but I will be covering definite integral by integration, by substitution. in the next one. Thank you for watching.